NFPA 780, the standard for the installation of lightning protection systems, offers direction on setting up these systems for structures and their contents. A key aspect to consider is Section 13.1.2.4 of NFPA 780, which clearly states that the lightning protection system should not be routed through or near pathways where people might gather or come into contact with it. This requirement is in place to prevent any potential electric shock or injury that could occur if individuals were to touch the system. When a bare copper conductor, part of a lightning protection system, is running along the interior surfaces of a building, it presents a tangible hazard. It is crucial to advise the customer to relocate the conductor to a less accessible location, ensuring people cannot easily come into contact with it. For further information and comprehensive guidelines, refer to NFPA 780 itself, the Lightning Safety Alliance, and OSHA's resources on lightning safety. These resources will give you a better perspective on lightning protection systems and the crucial safety precautions that must be adhered to when installing and maintaining them. The purpose of a lightning protection system is to protect a structure from damage caused by lightning strikes. These systems provide a low impedance path for lightning current to flow to ground, thus preventing uncontrolled strikes from traveling through the building, which can cause fire, explosion, and electrical damage. A typical lightning protection system consists of air terminals, also known as lightning rods, conductors, and grounding electrodes. Air terminals are installed on the roof of a building and are designed to intercept lightning strikes. Conductors are used to connect the air terminals to the grounding electrodes. Grounding electrodes are buried in the ground and provide a path for lightning current to dissipate into the earth. In addition to the physical components of a lightning protection system, there are also several important installation requirements that must be followed. These requirements are outlined in NFPA 780. One of the most important requirements is that the lightning protection system must be properly grounded. This means that the grounding electrodes must be installed in a location where they will make good contact with the earth. The conductors must also be properly sized and installed to ensure that they can carry the lightning current safely. Another important requirement is that the lightning protection system must be inspected and maintained regularly. This includes inspecting the air terminals, conductors, and grounding electrodes for damage. It also includes testing the grounding system to ensure that it is still effective. When designing and installing a lightning protection system, it is crucial to consider the potential hazards that the system could pose to people. For instance, as highlighted in NFPA 780, the conductors should not be routed in areas where people could come into contact with them. This is to prevent electric shock or injury. Therefore, it is important to carefully plan the routing of the conductors to avoid these areas. Here are some additional considerations for lightning protection systems. Firstly, a lightning protection system should be designed by a qualified professional. Lightning protection system design requires an understanding of electrical engineering principles and lightning phenomena. A qualified professional will be able to design a system that is effective and safe. Secondly, a lightning protection system should be installed by a qualified contractor. Lightning protection system installation requires specialized skills and equipment. A qualified contractor will be able to install the system properly and ensure that it is working effectively. Thirdly, a lightning protection system should be inspected and maintained regularly. Regular inspection and maintenance will help to ensure that the system is working properly and that it is safe. Inspections should be performed by a qualified professional. A lightning protection system is a critical safety feature for any building. By following the recommendations in NFPA 780 and working with qualified professionals, building owners can help to protect their buildings and occupants from the dangers of lightning strikes. Consider the building's construction type, height, and location, as these factors affect the system design. For instance, taller buildings and those in areas with frequent lightning strikes will require more robust systems. Also, ensure compliance with local building codes and regulations, which may have specific requirements for lightning protection systems. When routing conductors, avoid sharp bends and maintain a direct path to ground to minimize impedance. Use appropriate bonding techniques to connect all metallic components of the building to the lightning protection system. ensuring a common ground potential. Conduct regular inspections, ideally annually, to identify any damage or corrosion to the system components. Promptly repair or replace any damaged components to maintain the system's effectiveness. Keep detailed records of all inspections, maintenance, and repairs performed on the lightning protection system. This documentation can be valuable for future reference and insurance purposes. Educate building occupants about the presence of the lightning protection system and the importance of not touching or interfering with its components. Proper grounding is vital. The grounding system should have a low impedance path to earth. Use ground rods or ground plates, depending on soil conditions, to achieve effective grounding. Measure the ground resistance to ensure it meets the requirements of NFPA 780. If the ground resistance is too high, additional grounding electrodes may be needed. Proper bonding is another key element. Bond all metallic components of the building to the lightning protection system to equalize electrical potential and prevent side flashes. This includes bonding metal pipes, HVAC systems, and other conductive elements. Use bonding jumpers of appropriate size and material to ensure effective bonding. Surge protection is also something to consider. Install surge protection devices at electrical panels and sensitive electronic equipment to protect against voltage surges caused by lightning strikes. These devices divert excess voltage to ground, preventing damage to equipment. Select surge protection devices with appropriate voltage and current ratings for the application. Regular maintenance is required. Inspect the lightning protection system annually or after any significant lightning event to identify any damage or corrosion. Check air terminals, conductors, grounding electrodes, and bonding connections for signs of wear or damage. Repair or replace any damaged components promptly. Keep the system clear of any obstructions that could interfere with its performance, such as vegetation or debris. Documentation is also a key aspect. Maintain detailed records of the lightning protection system, including its design, installation, inspection, and maintenance. This documentation can be helpful for insurance purposes and for future inspections and repairs. In summary, lightning protection systems are essential for protecting buildings and occupants from the dangers of lightning strikes. By following the guidelines in NFPA 780 and consulting with qualified professionals, you can ensure that the system is properly designed, installed, and maintained. Regular inspection and maintenance are crucial for ensuring the ongoing effectiveness of the system. Remember that electrical safety is paramount, especially when dealing with high voltage systems like lightning protection. Always follow safety precautions and consult with qualified professionals when working on or near these systems. In addition to NFPA 780, you can also consult other resources such as the Lightning Protection Institute and the Electrical Safety Foundation International for more information on lightning protection and electrical safety. These organizations provide valuable information and resources to help you stay safe and informed. When considering a lightning protection system, it's important to understand the different types of systems available. Firstly, there is the conventional or traditional lightning protection system, which utilizes air terminals, conductors, and grounding electrodes to provide a direct path for lightning current to flow to ground. Secondly, there are early streamer emission ESC systems, which are designed to create an upward streamer earlier than other objects in the vicinity, thus attracting lightning strikes to the system. These systems are more complex and require specialized design and installation. Thirdly, there are charge transfer systems, which aim to reduce the potential difference between the building and the surrounding environment, thereby reducing the likelihood of a lightning strike. These systems are relatively new, and their effectiveness is still being studied. Selecting the right type of system depends on various factors, including the building's size, shape, location, and the level of protection required. It's important to consult with a qualified lightning protection specialist to determine the most appropriate system for your specific needs. The design of a lightning protection system should take into account the building's architectural features and the surrounding environment. Air terminals should be placed at strategic locations on the roof and other exposed areas to intercept lightning strikes. Conductors should be routed in a way that minimizes bends and provides a direct path to ground. Grounding electrodes should be installed in locations with good soil conductivity to ensure effective grounding. The system should be designed to protect not only the building structure but also its contents, including electrical and electronic equipment. Surge protection devices should be installed at electrical panels and sensitive equipment to protect against voltage surges caused by lightning strikes. In addition to protecting against direct lightning strikes, a lightning protection system can also help to mitigate the effects of indirect strikes such as ground currents and electromagnetic pulses (EMP). Ground currents can flow through the ground and enter the building through electrical and communication lines, causing damage to equipment and posing a safety hazard. EMP can induce voltage surges in electrical and electronic equipment, leading to malfunctions and failures. A properly designed and installed lightning protection system can help to reduce these risks by providing a path for ground currents to flow to ground and by shielding the building from EMP. When installing a lightning protection system, it's important to use high-quality materials and components that are designed to withstand the harsh environmental conditions to which they will be exposed. Air terminals should be made of corrosion-resistant materials such as copper or aluminum. Conductors should be sized appropriately to carry the expected lightning current. Grounding electrodes should be made of materials that provide good electrical contact with the soil. All connections should be made using approved methods and materials to ensure a reliable electrical connection. After the lightning protection system is installed, it's important to have it inspected by a qualified professional to ensure that it meets all applicable codes and standards. The inspection should include a visual examination of all components, as well as electrical testing to verify the system's grounding and bonding. Any deficiencies should be corrected promptly to ensure the system's effectiveness. Regular maintenance is essential for ensuring the long-term performance of a lightning protection system. The system should be inspected annually or after any significant lightning event to identify any damage or corrosion. Any damaged components should be repaired or replaced promptly. The grounding system should be tested periodically to verify its effectiveness. The system should be kept clear of any obstructions that could interfere with its performance, such as vegetation or debris. Finally, it's important to remember that a lightning protection system is not a guarantee against lightning strikes. However, a properly designed, installed, and maintained system can significantly reduce the risk of damage and injury caused by lightning. By taking the necessary precautions, you can help to protect your building and its occupants from the dangers of lightning. In summary, ensure the lightning protection system is not routed where people may contact it, seek guidance from NFPA 780 and related resources, and prioritize safety in all aspects of system design, installation, and maintenance. Remember to consult with qualified professionals and adhere to all applicable codes and standards.